What's up, party people? Let me get all this stuff out the way while my YouTube live continues to load. It's Mr. Harris, and yeah, we back. Unit 6, lesson 2. Now, Unit 6 is about the overall unit is about exponential functions, right? And so with exponential functions, we have to start out with exponents. So this video, I'm going to tell you about the rules of exponents. In the first video for lesson 1, we talked about a few rules of the exponents, the product rule and the quotient rule. We're going to go into some more rules this time. Remember, like, share, and subscribe. And watch the video. Like, take some time. Y'all help me get my numbers up. Help me get my viewing hours up. Please, please help me help you. All right, let's get into it. Excuse me. We're going to go, and I don't know why I keep showing this, but let's go presents, and we are going to start. We're talking about properties of exponents, and this is the extended version because we did some in the first one, right? So when I look at these, it says complete the table to explore patterns in the exponents when multiplying expressions with the same base. Okay, don't worry about the other piece right now. This is for my classroom. And so I want to show you all how we do these, right? So we're going to go, and this video is going to be a little lengthy, but it's all good. Y'all stick around. So I have 2 to the 5th power times 2 to the 3rd power. Notice they have the same base. Let's write them in expanded form. So I'm going to have 5 factors, all being 2. So 1, 2, 3, 4, 5. And then I have 3 more factors of 2 for the 2 to the 3rd power. Okay, so now if we count all these 2s, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 2s, right? So I can say 2 to the 8th power. All right, same thing here. I have 3, and then I'm going to have 7 3s. All right. So let's see how many total 3s do I have. I have 3 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Here, same thing. I'm just using x's now. X to the 2nd power is just x times x. X to the 3rd power is x times x times x. How many total x's do I have? I have 5. So that gives me x to the 5th power. Now, in this row D, notice I got to figure out, well, they give me the expanded form, and I have to actually write out the initial form. So in the first parentheses, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 m's. So that's m to the 9th power. And then in the second parentheses, I have 1, 2, 3, 4 m's. So that's m to the 4th power. And if I add up all those m's, I get 13 m's. So that gives me m to the 13th power. Now, this one is a little different because here, technically, if I write this in expanded form, I have 5 times y times y. That represents 5y squared. And then I have 4 times y times y times y, because that's y to the 3rd power. And then I just have times negative y. Now, this negative on the end here makes the whole thing negative. So I can actually take the 5 times the 4, and that gives me 20. And then I count up all the y's. 1, 2, 3, 4, 5, 6. So y to the 6th power. Okay. Next one, we're going to write it in expanded form too. We're going to say r times s times s times s. We need 5 of these s's. All right. And then the second parentheses, I have r to the 3rd power. So it's r times r times r. And then I have s to the 4th power. So I have 4 s's that I'm multiplying. And then now let's see, what do we get when we put it all together? How many r's do I have? 1, 2, 3, 4, 5. So I have r to the 5th power. And how many s's? 1, 2, 3, 4, 5, 6, 7, 8, 9. So s to the 9th power. All right. So we're doing expanded form. This is for the more basic level, but some people may be able to skip through these things. I just want this when it gets to being when we're incorporating multiple rules together. writing it in expanded form sometimes will definitely help you. Okay, let's clear these and let's go on to the next slide. Let's see. All right, so here, notice it's power of a power. Okay, so this one's going to be a little different. We're still writing it in expanded form, but notice in this example, I have 3 to the second power in parentheses, and then I have the exponent of 5 on that. So what this is saying is 3 to the second power multiplied by itself 5 times. So that's why you see 3 squared, 3 squared, 3 squared, 5 times, right? But then if I expand each 3 squared, then it's 3 times 3. All right, and once again, it's 5 times. And then I just add up all those 3's and I get 3 to the 10th power, okay? So when I look at A, I'm going to say 2 to the 3rd power, and it's going to be 4 times. All right, so then now let's expand each of those. 2 times 2 times 2 in each parentheses. And we're going to do that 4 times. All right. All right, so now how many total 2's do I have? I know the base is going to be 2. 12. Okay, 2 to the 12th power. Here, I have x to the 4th times x to the 4th, right? So now I know I have x to the 4th, and that's taken to the 2nd power, okay? How do I know that? I have x to the 4th times x to the 4th. And based on the rules of exponents, or exponent is multiplying something by itself several times. Then when I expand it, I have 4x is there, 4x is there. I get x to the 8th power. Hopefully by now you're seeing a pattern on what to do whenever you have an exponent or a power taken to another power. So here I have xy squared times xy squared times xy squared. Well, why did you do that, Mr. Harris? Because I have xy to the 2nd power, and all of that in parentheses is taken to the 3rd power. So I have to have xy squared 3 times, okay? So now if I want to expand this, this is x times y times y. Just a minute. And then x times y times y. And then x times y times y, all right? So let's put it all together. How many x's do I see? I see 3 x's. So x to the 3rd power. And then how many y's? I see 1, 2, 3, 4, 5, 6. Y to the 6th power. And that's it. We don't know what the value of x or y is, so we can't do much more to it. But when we get to D, we're going to see a little more. 6n to the 4th power. All right. And we're going to do that 3 times. Okay. Now we're going to expand each of those parentheses. So 6 times n, 4 n's. Okay, so 6 times n, 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 and then 6 times n, 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 and n. Hopefully I didn't forget an n. All right, so now we've got to do 6 times 6 times 6. Well, 6 times 6 times 6, I believe, is 216. So you can't forget to multiply that coefficient. And then I have n, and how many n's do I have? 4, 5, 6, 7, 8, 9, 10, 11, 12. So 216n to the 12th power. All right. This one, -3 r to the 3rd power, s to the 4th power. And it's all taken to the 2nd power, so I'm going to multiply it again. All right, if I expand that out, I have -3 times r times r times r times s. And then I'm going to do that again, -3 r, 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 S, 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 S. Okay. So -3 times -3 is +9. How many R's do I have? 1, 2, 3, 4, 5, 6. So R to the 6th power. How many S's? 1, 2, 3, 4, 5, 6, 7, 8. S to the 8th power. Okay. So if you notice, there is a pattern here. And what this pattern looks like, let's see, it may be on the next slide. Let's check to see. All right. So here it doesn't list it, but I'm going to list it for you all. What this says is if I have x to the a power, and that in parentheses is taken to the b power, then I get x to the a times b power. Okay, so what it's saying is you're going to multiply the exponents in this case. Now, remember, if we look a little closely, everything in parentheses ends up getting taken to that power that's on the outside of the parentheses. So that's why these look really long. Okay, so if you notice, when you end up with, you got 6, notice there's 3 6s. Okay, notice there's 3 n to the 4th power. Okay, but this is your rule. That's called the power of a power. Go on to the next one. All right. So here we're going to kind of just do some examples of that. I'm not going to write these out in expanded form just for the sake of time. I don't want this video to be too long. Okay. So if I have x to the 5th power squared, then I have x to the 5th power times x to the 5th power. All right. Y'all excuse me. For some reason, there's an Amber Alert coming in while I'm live on YouTube. Hopefully they find the child. All right. And then I have times x to the 3rd power. Okay. So notice our product rule says if we have the same base and different exponents, we can add the exponents. So this is basically x to the 5 plus 5 plus 3 power, which ends up giving us x to the 13th power. Okay. So notice I expanded the first one. So I used the power of a power rule, and then I simplified by simply using the product rule. Here, same thing, 6y to the 3rd power times 6y to the 3rd power, because it's taken to this power, and then I multiplied that by y to the 4th power. Okay, 6 times 6 is going to be 36. And then I'm going to say y to the 3 plus 3 plus 4 power, which equals 36 y to the 10th power. All right. Over here. So let's see what we have. RS to the 2nd power. And then I have r to the 6th power taken to that power. So I have another r to the 6th power. And then I have a s. Okay. So we don't have any coefficients, but let's see how many r's we have. So I have basically r to the 1 plus 6 plus 6 power. You might say, well, Mr. Harris, there's no r to the 1 power. Well, if it does not have an exponent on it, it's considered to be an exponent of 1. And then here I have s to the 2 plus 1 power. This s is considered to the 1 power. Okay, and I simplify that. I get r to the 13th power. All right, so r to the 13th power, s to the 3rd power. Okay. Let's do this last example, and let's do it in a different color. So I have 3m and 3m because it's taken to the 2nd power, and then I have 2m to the 4th times n to the 7th. All right, let's multiply out these. So let's do this. 3 times 3 times 2. And then I have m to the 1 plus 1 plus 4 power. And then n to the 7th power. Okay. And we can simplify that 3 times 3 is 9. 9 times 2 is 18. So 18m. 1 plus 1 plus 4 is 6. And then n to the 7th power. Okay, so be very, very careful. Take your time when you're doing these because they start to include more than one rule. All right. Here's another one. Now, there's some pieces on this particular slide that I wouldn't present it like this, but I understand why they present it like this. So I'm going to scratch out a bunch of stuff on here first because I don't want anyone to be confused. But then again, actually, I'll explain it because I want, if you're not my student and you're watching this, I want you to understand why they're showing this. Or if you're a parent, I want you to understand why they're showing this. This is where that new math stuff comes into play. So here, as you can see, we have 2 to the 10th power. Our goal is to write this with the fewest number of exponents. So I have 2 to the 10th power over 2 to the 3rd power. This right here is just showing you where you cancel out 3 2's, okay? They all divide to equal 1. So that's where this 1 comes from. And then we have these 7 2's, which is where we write the 2 to the 7th power, okay? So 2 to the 7th power times 1 is just 2 to the 7th power, as you can see over here. Now, when we look at this second example, they took the 8 and they broke it down into factors 2 times 4. They took the x to the 5th power and wrote it down as 5 x's. On the bottom, they did 6 and they broke it down into 2 times 3, which is just factors, and then x is written in expanded form. So notice in this middle part, they actually have this right here is what we can cancel out because here 2 over 2 and then x, 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 x. So that's what that comes from. Okay. So I'm left with x times x. And that's that. And then I'm left with the 4 and the 3. So that's where this comes from. Okay. So notice here, I'm left with 1 because that comes from here. And then 4x to the 2nd power. All right. So I'm not going to do these bottom ones exactly like that. I can, but well, yeah, let's do it like that. Let's say, excuse me. So 15 is equal to 5 times 3. And then x, 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 x. And on the bottom, I just have 5 times 1 and x, x. All right. So what divides to be 1? Okay. Well, 5 divided by 5 equals 1. X divided by x equals 1. X divided by x equals 1. So I'm left with 3 and then x to the 4th power on top. And then there's nothing on the bottom. So it's just 1. So it's 3x to the 4th power. All right. Here, I'm going backwards. In this next example, I'm going backwards. So 2 times 5 is 10. And then R. So 1, 2, 3, 4, 5 R's. So 10R to the 5th power over 2. I got 2 and then R to the 3rd power. Okay. Well, 10 divided by 2 is 5. And then R to the 5th power over R to the 3rd power. We take 5 minus 3 for the exponents. And we're left with R to the 2nd power. Okay. Don't be confused by this. All this is just what can divide out to be 1. Okay. So here, and I'll show it to you. That 2 crosses out. That R, that R, that R. All right. So we have a 2 R in the numerator, which is here. And then same thing in the bottom, 2 R. And so this turns into that 1. And we're left with the 5 up top and 2 R's. So that's what we get, 5R squared. All right. For this one, I'm going to speed up a little bit and write this one a little different. I'm just going to keep it as -8. And then I'm going to say m to the 4th power, n to the 7th power over 2 m to the 3rd power, n to the 1 power. So I'm going to write this a little different. -8 divided by 2, and then m to the 4th over m to the 3rd, and then n to the 7th over n. All right, well, how does that work? Negative 8 divided by 2 is negative 4. M to the 4th over m to the 3rd. We subtract the exponent, so 4 minus 3 is 1, so that leaves me m to the 1 power, or just m. And then n to the 7th over n. We subtract the exponent, 7 minus 1. Remember, if it doesn't have an exponent on there, it's considered 1. So I let 7 minus 1 is 6, so n to the 6th power. All right. Same thing. I'm going to do this on the bottom, right? So 6 x y to the 3rd. We could do this one the new math way. 6 is equal to 3 times 2. Let's do a different color. 6 is equal to 3 times 2, and then times x times y times y times y. And then 15 is equal to 3 times 5. Okay, times y times y. Notice we're looking to see what factors we can cancel out. So even when we have that coefficient, we want to break it down into factors that will divide into 1. So 3 divided by 3 is 1. I don't like that color. Let's go black. 3 divided by 3 is 1. Y divided by y is 1. Y divided by y is 1, right? So we're left with 2 x, y in the numerator, and then we're left with 5 in the denominator. So your answer is 2/5 x, y, or you can write it just like you see here. They both are the same thing. If I shave my beard tomorrow, I will be the same person, just look a lot different. All right. Next slide. We're going to talk about now, we're still talking about quotient of powers, but we're talking about, you're going to see something from this one. You should notice a pattern. Okay. Here, if we stick with the rule, the quotient rule that says x to the 3 minus 3 power, that gives us 3 minus 3 is 0. Okay. So that gives us x to the 0 power. All right. Same thing here. We have r to the 4 minus 4 power, and that gives us r to the 0 power. Okay, same thing here, m to the 5 minus 5 power, it gives us m to the 0 power. Well, this middle part shows us exactly why any number to the power of 0 equals 1. So in the A, we wrote out x, x, and x, right? And in the denominator as well. So now remember, any number divided by itself equals 0. So here I have, I don't like these colors. Let's get a different color. Let's go here. So x divided by x, x divided by x, x divided by x equals 1. Same thing here. Boom, 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 boom. That's 1. Boom, 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 1. So x to the 0 power, or any number to the 0 power, equals 1. Okay? And if you look up here in number 2, I kind of skipped this. So I could say x to the a power over x to the b power is equal to x to the a minus b power. And then here, use your rule to write the following with a single exponent. So x to the 0 power. Remember, any number to the 0 power is going to equal 1. And it's going to ask that question again, I believe. Oh, actually it doesn't. All right, so let's put it all together. So I have x to the negative 7 power times x to the 3 power. And now you got a negative exponent in that first one. So I have x to the negative 7 plus 3 power, which equals x to the 4th power. I'm sorry, negative 4 power. All right. So it says we want to rewrite the expressions using rules of exponents. The final expression should include only positive exponents. All right. So how would I write this? Okay. Well, we technically haven't done the negative exponent power. So let's look at this right here. So x to the negative 4. Well, how do I write it as a positive exponent? Okay. Well, x to the negative 4 power is the same thing as saying, so let's look at this. 1 over x to the 4th power. And I'm going to prove this to y'all in a little bit. All right. So I have 2 taken to the negative 3 power, r taken to the negative 3 power, and s squared taken to the negative 3 power. Okay. And if I use these rules, this is 1 over 2 to the 3rd power times 1 over r to the 3rd power times 1 over s to the 6th power. Well, how'd you get the 6? Well, remember, you got to multiply these exponents, okay? And how did you get this rule, Mr. Harris? Why did you make a fraction? We're going to show you that in the next step, okay? And really what technically happens is, I'll show you in just a second. So 8m to the 6th over 4m to the 9th. 8 over 4 is 2. M to the 6th over m to the 9th is m to the negative 3 power. Okay, so what I have is 2 over 1 times 1 over m to the 3rd power, which gives us 2 over m to the 3rd power. I believe there is let me see if there's another slide here. There is, okay? So these still negative exponents. I actually don't, let me see how much time I've been on here. How much time have I been up here? It's pretty long right now. Oh, we can do this real quick. Let's do it real quick. Remember, this is, if I have a negative exponent, I have 1 over 3x squared y. And then times 6x cubed y to the 4th over 1. All right, so that equals 6x to the 3rd, y to the 4th, over 3x squared y. All right, 6 divided by 3. Okay. 6 divided by 3, and then x to the 3rd over x squared, and then y to the 4th over y. And so 6 divided by 3 is 2. X to the 3rd minus x over x to the 2nd is x, because 3 minus 2 for the exponents. And then y to the 4th over y is y to the 3rd power. All right. Number 5, remember, we're taking this to that power and this to that power. Okay, so I have r to the 4 times 3 power, s to the negative 2 times 3 power over r s to the 4th. Remember, the denominator is standalone. So I have r to the 12th power, s to the negative 6th power over r s to the 4th. So now I can break these powers up and I can say r to the 12 minus 1 power, because remember, if it doesn't have an exponent, it's considered 1. And then s to the negative 6 minus 4 power, which equals r to the 11th, s to the negative 10. And I take that and I say r to the 11th over 1 times 1 over s to the 10th. And I get r to the 11th over s to the 10th. You may have to stop and look at this one, rewind it a couple times, things like that. I feel like there's a slide missing because I can't see where we derived the negative exponent rule, okay? And so I'll cover that just a little bit. Let me see if there's another slide on here first. There isn't, okay? So let's go back. When we talk about negative exponents, right? I don't have that slide up here, but for the sake of being live, let's do it. So let's go to the whiteboard, right? So let's say if I have r to the second power over r to the fifth power, right? We're talking about the negative exponent. Okay, so negative exponents. All right. So how do we get this rule? Well, if we write these out in expanded form, r to the second power is r times r, and r to the fifth power is 5 r's, right? So now, how many r's can divide out to be 1? Boom, 1 right there, 1 right there, okay? And we're left with 1 up top because those canceled out to be 1, and then we have r to the third power. Well, if I go back and do my quotient rule, which tells me r to the 2 minus 5 power, that gives me r to the negative 3 power. Okay, so this is the same as this. Here's how we derive that. Let's say we do it with just some variables, right? So let's say if I have x to the fourth power over x to the sixth power. That gives me x to the 4 minus 6 power, which is x to the negative 2 power, okay? And if I wanted to write this out, let's do this. X times x times x times x. And then I have 6 x's on the bottom. All right, let's see how many cancel out or divide out to be 1. Boom. I have a 1 up top and then x squared on the bottom. So this and this are the same. That's where we get the negative exponents rule, okay? Hopefully this has been helpful. Do me a favor, like, share, subscribe, share with the homies. Stop, rewind, do what you got to do, because some of this stuff, when you start putting it all together, can stack up on your brain pretty fast. But just take your time. Remember, all we're doing at the end of the day is multiplying, dividing, adding, and subtracting, okay? Simplifying fractions. So we're at this point in your math journey, you're going to combine a lot of rules together, right? But do one rule at a time. And if you do that, I guarantee you'll get a better understanding of this. Thank you all for watching. Share this with somebody. And remember, like, share, subscribe. I got the solution to your math problems. Deuces.